Hello everyone, I am Mohammad Asif. Hope you are enjoying good and happy life. We are starting our new chapter today. The name of the chapter is the speed of reaction. If we define speed of reaction, the definition of speed of reaction is rate of change of concentration of reactants or products. This is called rate of reaction. The definition is rate of change of concentration of reactant or product. Anyone. Either the change in concentration of reactant we can take, or either the change in concentration of products. Both have the same meaning. If we write mathematically, rate of reaction is, this is del C stands for concentration, del means change in concentration, divided by del T means change in time. The rate of change of concentration with respect to time is called rate of reaction. From this mathematical expression, the unit of rate of reaction might be, the unit of concentration is mole per dm³, and if the time is taken in second, then the unit will become mole per dm³ per second. This is the definition of rate of reaction. This is the mathematical form, and this is the unit used for the rate of reaction. Now, depending upon the rate of reaction, there are three types of rates which we normally observe in our life. One are the fast reactions. Second are moderate or spontaneous reactions. And the third one are slow reactions. In our daily life, we observe all of these. Fast reaction, those reactions which takes place within no time, which are completed within no time. For example, if we strike a matchstick, immediate ignition takes place. This is the example of fast reaction. Similarly, whenever explosion takes place, too much amount of heat energy and gases are produced, and those gases and energy has no time to escape out. That's why explosion takes place, and this explosion takes place within no second. That's why this is also an example of fast reaction. Simply we can say those reactions in which time for the completion is minimum, nearly equal to 0, that will definitely gives us the fast reaction. The seconds are moderate or spontaneous reactions. Those reactions which move with a little bit slow speed. In case of moderate and spontaneous reactions, we can easily measure their rate of change with respect to time. For example, For example, if we react calcium carbonate with HCl, whenever we combine both of these substances, a spontaneous reaction takes place. Immediate reaction takes place, producing calcium chloride, then carbon dioxide, and then water. These are the products. This reaction is example of moderate or spontaneous reactions, and this reaction can be performed in both of these experimental apparatuses. This is an example of moderate reaction in which we can easily calculate the rate of reaction. Similarly, hydrolysis of esters. Hydrolysis of esters. Esters are, for example, this is CH3, COO, C2H5, say this is ethyl ethanoate. When this ester is hydrolyzed in the presence of mineral acid, then it produces respective carboxylic acid and also the alcohol. Now, this reaction also proceeds at a normal speed. We also decrease the speed of this hydrolysis reaction using very low temperature, putting some ice into the reaction mixture and then taking sample and then titrating this acid produced against standard alkaline solution, calculating the concentration produced of the acid. With the passage of time we can calculate, and the speed of this reaction is neither too much fast, neither too much slow. We can easily observe the rate of reaction in this case, and this is also an example of moderate or spontaneous reaction. Now, the third one are slow reactions. Slow reactions, those reactions which take too much time for the completion. For example, rusting of iron, it is too much slow. Similarly, ripening of fruit, this process is also too much slow. In the similar manner, the rotting of food, and this is also a slow process. This relates with the change in temperature. All these are examples of slow reactions. These are the three types of reaction. Now, basically, in this chapter, we have to discuss only this second type of reaction, moderate or spontaneous reaction. As I have already explained, as I have already told, that the reaction between calcium carbonate and hydrochloric acid can take place and will produce calcium chloride, carbon dioxide and water, and both of these laboratory apparatuses can be used. Now, there are so many methods. These indicating two methods. The first method is based on the change in mass with respect to time. As the reaction will proceed, the gas produced will be escaped out. How we will perform this? Whenever we will add hydrochloric acid in the marble chips which are already present in this conical flask, immediate reaction, spontaneous reaction will start producing this gas. We will put a cotton plug here just to allow the gas molecules to escape out, but not the water molecule or water vapors. At the same time, immediately when reaction will start, we will also start the stop clock. by taking a suitable time interval. Say if we have to decide, note down the value of change of mass after 1 minute or 2 minutes. We will start noting the reading of loss of mass or decrease of mass, and we will definitely get a data with respect to time, change in mass of the reaction mixture. Now, this second apparatus is also used. The chemicals are same, but in this case, the gas produced is collected in the gas syringe attached. Now, there is a conical flask, marble chips are already present, and hydrochloric acid is present in this tap funnel, and this gas syringe is attached. Whenever we will allow hydrochloric acid to drop into the conical flask, we will start this stop clock immediately, and the gas produced will be collected in the gas syringe, and we will note down the volume of the gas collected in the gas syringe after each regular interval of time. There are so many other methods in which temperature change can also be used, in which pH change can also be observed, in some reactions color change can also be taken, and the data is obtained. There are so many methods, but whatever the method we use, we have to collect the data with respect to time, the change, either the change in color, pH, volume, mass, or whatever the case, and we have to plot a graph for the given data. Now, when we plot a graph, from graph we can easily calculate the rate of reaction, both average and spontaneous reaction. For example, if we plot a graph between this, with respect to time, change in mass of this reaction contents, we will calculate and then plot a graph. Suppose this is our zero value, and this is the time 2, 4, 6, 8, 10, 12, 14. See, this is the time in minutes. And here in this side is the change in mass change. Now this is the change in mass, say again 2, 4, 6, 8 and 10. See, this is the change in mass per gram. These are the grams which are going to change. If we plot a graph, then definitely the graph will go just like this. Just like this. Now, in the beginning, the reaction will be much faster because the concentration of both reactants will be maximum in the start, and the rate of reaction is directly proportional to the concentration of the reacting substances. That's why initially the rate of reaction will be very fast, and there will be a large change in the beginning. But as the time will moving on, the concentration of the reacting substances will decrease, and the rate of reaction will become slower, and automatically the change which is going to take place in the mass of the reaction contents will also be decreases. Now, the points from where we observe that this graph is becoming parallel to the time axis, it means that at that time the reaction is completed. No further change is taking place. A constant value will be observed that will indicate the reaction is finished at 10 minutes. Now, if we want to calculate the average rate of reaction, then we will take the total change in mass taking place in 10 minutes. Say it is 8.2 gram. This is a total mass change from initial to this final step. Now we will divide this total mass change by the total time taken, that is 10 minutes. Then what will be the rate of reaction? This calculation will indicate the rate of this reaction is 0.82 gram per minute. This is the average rate of reaction because we have taken the total mass change and divided by the total time taken for till the completion of the reaction. As a result, we get average rate of reaction. This is average rate of reaction. But if we want to calculate the instantaneous rate of reaction at any particular time, then what we will do? Then we will draw a perpendicular from that time interval to the curve and then draw a tangent at this point. Tangent is the straight line touching the curve outside. Now, then we will select 2 points above and below the point of tangent and then draw a right angle triangle at this point. Now, this is a right angle triangle. For this right angle triangle, the total time taken is this, from point this to this. For example, this is the point 8.8 value. Minus will be from here. Suppose this is the value 3. Then 8.8 minus 3. Total time will comes 8.8, then 3.0. What will be the answer? 5.8. This will be the total minutes taken for this right angle triangle. Now, if we want to find out the total change in mass at this point, that will be these 2 points. These 2 points. Now, say from 6.2 to 8.4, this change is taking place. From 6.2 to 8.4. See, this is 8.4 and start from 6.2. What is the total difference? This is a 2.2. Means for this right angle triangle, the total mass change is 2.2 grams in 5.8 minutes. Now, the rate of reaction at the time 6 minutes, the rate of reaction will be 2.2 divided by 5.8. By calculating, we can easily find out, for example, removing both of these decimals and then simplifying this. This will become 11 by 29. 11 by say 29. This is 30. Approximate. This is a 1/3, 0.313. This is gram per minute. Now, this answer will be The instantaneous rate of reaction at the time when time is 6 minutes. Similarly, we can calculate the rate of reaction at any other time interval at 2 minutes, 4 minutes, 5 minutes, 6 minutes, 8 or 10, whatever the case. But this is quite clear. If I have taken the point for tangent here, the slope is less. If I will take the point at the curve for tangent here, the gradient will be large and automatically the gradient at the start will be maximum. In this manner, using the graphical method, we can calculate average rate of reaction or the rate of reaction at a particular time, existing time, 6 or 4 or 6 minutes. This will be called as the instantaneous rate of reaction. In this manner, rate of reaction can easily be calculated. I have explained all of the concept which relates to this topic, the speed of reaction. I hope you have understood completely. In case of any problem, you can leave the question at the page Study of Change.